All right, this video is designed to help you figure out these last couple of questions on the People Power Lab. Number 5 asks, suppose you could run up the stairs continuously for 1 hour straight. How much would your climb be worth if you could sell that power at the same 10 cents per kilowatt hour that the power company charges you? Well, the first thing is to understand what your power is. Now, we're using the numbers that I had given you in Google Classroom for, I think it was a 160-pound person. And for a 160-pound person, we know that in order to climb up, we first did these calculations at the beginning of the lab. So your power output is going to be different than the power output I'm putting here because this was for a 160-pound person going up the 4-meter high flight of steps in, I think, 6 seconds. And that got me a total of 475.2 watts of power when I calculated. Again, your number is going to be different, so you have to use your numbers. And ultimately, what that 475.2 means is I would exert 475.2 joules of energy every second that I go up the stairs. So now it's important to figure out, well, if we're talking about a kilowatt hour, ultimately that is saying and a total amount of energy used in an hour. So if my power is 475.2 watts and I do that for 1 hour, how much energy am I using? So basically what that's saying is if I am using 475.2 joules every second, and I do that for an hour, which happens to be 3,600 seconds, then my total amount of power or work done, my total amount of energy spent or my work done is 1,710,720 joules of work. Now what we have to do is figure out, well, how much money is that worth? Well, we know that 1 kilowatt hour of power is really 3,600,000 joules of energy. And the power company charges 10 cents for that amount of energy. So if I do 1.7 million joules of energy here, that's how much I spent. And I'm going to get 10 cents per 3,600,000 joules of energy. By multiplying that, I find out I am getting a little less than 5 cents worth of energy for that hour of climbing the stairs. Number 6 talked about a 60-watt light bulb and how long would that have to burn to produce the same amount of energy as you climbing the stairs once. Well, now we need to know how much energy you spent climbing the stairs once, and that is going to be the work that you did to climb the stairs. If I, again, use my 160-pound person, I had to convert that weight to newtons. You would have your own amount of work that you did by multiplying your weight in newtons times the height of the stairs. And you will find your own work number. It's going to be something different than this one. But if this is your work number, 2,850.9 joules of work / energy used to climb one set of steps. So how long would a 60-watt light bulb have to be on to use 2,850.9 joules of energy? Well, 60 watts, again, means 60 joules of energy every single second. So the question is, how many seconds does that take? Well, here is my total energy times 1 second per 60 joules, because that's ultimately what the light bulb is doing. And I get 47.5 seconds is how long the light bulb needs to be on. Number 7. So now we're going to be able to turn all of our power going up the stairs into electrical power. And ultimately, how high would we have to climb to make 1 penny's worth of electricity? Again, knowing 1 kilowatt hour is 10 cents. So ultimately, if a kilowatt hour is 3,600,000 joules of energy, a single penny is only 1/10 of that amount. So that's 360,000 joules of energy. So the question is ultimately asking, how high do you have to go to exert 360 joules of energy or do 360,000 joules of work, same thing. So the energy that we're going to be going up climbing the stairs is the work it took you to climb up the stairs. So that's the amount of force for your weight. Now, again, for a 160-pound person, your weight in newtons is 712.7. Your weight is going to be probably something different. So how far would I have to go to do 360,000 joules of work? If I know that my force is 712.7, I'm going to use the work equation. The work equation is my force multiplied by my distance equals the total work done. So force times distance equals work. And I'm going to be solving for the distance, so I have to divide by 712.7 over here to the right side. So 360,000 divided by 712.7 gets me 505.12 meters. So I have to climb 500 meters worth of steps to basically do a penny's worth of work. If one food calorie is 4,186 joules, then how far would you have to climb to burn off a 50-calorie Oreo cookie? Well, first we need to make sure that we know how many total joules we're talking about. A 50-calorie cookie is going to contain 209,300 joules of total energy. Now we know that we're exerting a force of 712.7 newtons. We talked about that in the last question. So how far do you have to go to do 209,300 joules of work? Because that's how many calories, or not calories, joules we need to burn off for that 50-calorie cookie. So it's going to be the same type of equation as last time. We're going to do the work equation. So the force is still our weight, 712.7, times how high we are going to be climbing, equals the joules that we're trying to burn off from this 50-calorie cookie. And when we do a little bit of algebra, we find that that's going to be just shy of 300 meters. Again, this is for the weight that I have here. Your weight's going to be a little bit different. So you might have to climb a little bit more or a little bit less, depending on how much you weigh. Finally, how many stories is that? Like how many floors is that going to be? Well, if one floor is 3.9 meters, again, people measured the distance from the first floor to the second floor of the high school, depending on if you did roughly 17 centimeters a step. Some people did at 17 and a half centimeters, kind of depended on where you decided to round that. It was somewhere in the ballpark of 3.25 to 4 meters from the first floor to the second floor. So I just guesstimated roughly 3.9 meters per floor, and we're going to travel 293.7 meters. So if one floor is 3.9 meters, and we're going to go a total of 293.7, basically we're just dividing our total distance by how many meters per floor, and that gives me 75 floors is how many stories of a building I'd have to climb to burn off my one Oreo cookie.